Okay, guys, this is 7-2. Okay, so we're talking about similar polygons. Don't get similar confused with congruent. Okay, so if I accidentally hole punched your similar, that is supposed to be the word similar. Okay, and this is what similar polygons mean. They are the same shape. They are the same shape, but not necessarily the same size. Kind of like a model and an actual. There can be a smaller figure and a bigger figure. They're the same, they're similar, they're the same shape, but they're not the exact same dimensions. Okay? So you see these two triangles right here. They're the same shape, but they're not necessarily the same size. So we have to go through a couple of procedures to prove that polygons are similar. Okay, now think in your head real quick. Think about a 6-inch triangle. Got it? 6-inch triangle. Think about a 6-foot triangle. 6-foot triangle, 6-inch triangle. What is the inside measure of the degrees of the 6-inch triangle? Think about it. What is the measure of the inside of the 6-inch triangle? How many degrees? 180. Right? Okay, well, what's the measure of the degrees of the inside of the 6-foot triangle? 180. So I tell you that to prove that you're going to have corresponding angles, but really, all of your angles are congruent to each other. So your angles are congruent, and your sides are what we say corresponding. So I'll usually talk about your angles being congruent, not corresponding, but you could. So all of your angles have to be congruent to the other polygon. So in this example, what kind of polygon is this? What kind of polygon? Quadrilateral was what I was looking for. 4 sides, right? Okay. So A. A has how many rainbows? 1. So it's congruent to what?
W.
That's where we got this. A congruent to W. B has how many?
2.
So it's congruent to?
X.
That's where we get this. C has?
3.
So it's congruent to?
Y.
Which is where we get this. And last but not least, D has 4. So it's congruent to? Z. Okay, now you might have to list your congruent angles. That's one way to do it. Another way to do it is by looking at the name of them. Notice, A and W are both first. So first and first are congruent. Look, second and second are congruent. Third and third are congruent. D and Z are fourth and fourth, and they're congruent. Okay? So those are just your angles. You're used to doing that by congruent triangles. Now, let's talk about corresponding sides. So, corresponding sides, it has to be the same position, but in both polygons. For example, we go 1 rainbow to 2 rainbows. Well, that's talking about this side right here. And I'm putting a dot instead of a dash. Why can I not put dashes? And they're not, right? Okay, so this is A to B, and it's corresponding with WX. Because they're both 1 angle to 2, 1 rainbow to 2. Okay, well here's 2 rainbows to 3, so 12 is corresponding to 4. 2 to 3, 2 to 3. Okay, 3 rainbows to 4, 3 rainbows to 4, so this is corresponding to this. And then lastly, this side is corresponding to this side. So that's where they got all of these dimensions right here, or these names. AB to WX, BC to XY, CD to YZ, and DA to ZW. So now what I want us to do is I want us to go in and plug in all of the distances of these. So AB is how long? So put 15 to WX is 5. So 15 to 5. You have to go in order. So if you start with this polygon, you have to start with this one every time. So now BC is 12 to 21 to DA 2. Okay. Here's how we tell if these two polygons are similar. If you take your calculator and you plug in all of these in, do they all have the same thing? Yes, they all reduce to 3 to 1. By that, because their scale factor, does this have units? So this is your scale factor. SF stands for scale factor, not San Francisco. Ha 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 ha. Thank you. Okay, because they all have the same scale factor, these are similar. Now, when it says write a similarity statement, this is your similarity statement. Notice, there's a new symbol. It's called, I don't know, I just know it's a tilde in Spanish. I don't know if there's a real name for it in math, probably so. It's the squiggly line from this. Two different symbols. This means similar, this means congruent. Don't get them confused. Okay, example 1. So here in example 1, it's telling us they're similar. We don't have to prove it. If this is similar to this, list all pairs of congruent angles. There's two ways to do this. You can either just look at the statement, or you can look over here. I choose to look at the statement because it never leads me off the wrong track. Okay, so what's the first angle you see? F. So F is congruent. You can use congruent because the angles are. F is congruent to angle J, first to first. Our second angle is G, and it's congruent to angle K, first to first, second to second. And then our third angle is H, and it's congruent to angle L. Will someone open the door? Hello, you can sit in the back. James, will you shut the door? Okay, now let's do our sides. Okay, so we got all three angles. Let's do our sides. Now, if you want to, you can go over to these triangles and put one rainbow to 1, 2 to 2, 3 to 3, and then follow what we did up here. Or you can keep following this, which is what I like to do. Because the first two, FG, goes with the first two over here, which is JK. So the first ratio is FG to JK. So it's first to second, which equals 2 to 3, which is GH. So GH to KL. Are y'all following along with me? And then I mean, you could do HF. I do FH. FH first to third to JL. But keep in mind, HF and FJ are the same thing, so I wouldn't mark you wrong for that. Okay, if you don't like following this right here, and you've already marked your angles over here, couldn't you follow the same thing? First to second, first to second. It's the same exact thing. Yes? No. Okay, great question. It does not matter which one you start off with first, but if you start with this one, then every time this one has to be in the numerator. Does that make sense? Okay. Great question. Okay, now let's move on. Scale factor is back. Remember, a scale factor has no what? Unit. It is the ratio of the lengths. It's the ratio of the lengths of corresponding sides of similar polygons. Ratio of the lengths of corresponding sides of similar polygons, which is what we found up here. Which is what we found up here in this example. This was the ratio of the lengths of corresponding sides. Okay, now on this star right here, it says the scale factor depends on the order. That's what Lakeland just asked about. Up here, the scale factor was 3:1 because we used this polygon first and then this one. Well, what if I would have flipped that? If I would have done this one, then this one. The scale factor would be 1:3. And that's fine, just be consistent. Okay, so technically, as long as you show everything correctly, your scale factor could be 1/3 and not 3:1. Okay? Okay, next page.
So we don't have to worry about if it does have
Any units? Right. If it asks for the scale factor. Okay, look at this cute puppy dog. Just makes math so much more fun when you include dogs. Okay, Kuma has this cute Dalmatian with 101 spots. That's going to go on her computer, okay? And her computer's desktop is a rectangular shape. So this is the OG. This is the original picture of Kuma's pet dog. Okay? Okay. So you have answer A and answer B. We want to know which one, answer A or answer B, is similar to the original. So let's write a ratio to determine which one of these is similar. So it doesn't matter which side you start with, but we have to be consistent. So do y'all want to do 8:10 or 10:8?
8.
Okay, well, I heard 8:10 first. So the scale factor of this image is 8. Well, technically it's a ratio right now because I have inches in there. So the ratio is 8:10. Can I reduce that?
Yes.
Let's reduce it. Divide both by what? I do 2. So we get 4 to 5. Now, is this a ratio or a scale factor? Scale factor, because the scale factor has no what? Unit. Okay, now, we started with the side first. So when we're finding the ratio or scale factor of both of these, we have to start with the side first. So it's going to be 12 to 14 and 12 to 15. We'll reduce both of those and see if any of them have a scale factor of 4 to 5. Yeah, I got B. Right? Because this one just reduces to 6/7. So let's read the instructions and make sure we've answered everything. Determine whether the following rectangular images are similar. If so, write the similarity statement and scale factor. Okay, so our answer was B. What's the scale factor? 4 to 5. And let's write a similarity statement. Rectangle. Let's start with the OG first. How would we name this rectangle? ABCD is similar. Don't write the congruency symbol. Similar to rectangle. What? JK. I'm not JKing. Ha ha ha. That's okay. Because they both have the same what? Scale factor. Okay? Alright, let's go to practice number 1. Okay, instructions say, determine whether each pair of figures is similar. If they are, write the similarity statement and the scale factor. Okay, so in order for these to be similar, they have to have 3 congruent what? No, 3 congruent angles, and 3 corresponding sets of sides that have the same scale factor. Is anybody in here besides Kalia?
No.
Okay.
So what was
And Maddie. Okay, so let's put our rainbows. I like rainbows because y'all know I like happiness and sunshine and jokes, and y'all laughing at my jokes. Okay, A is congruent to what? D. C is congruent to F. Now remember back from chapter 2. No, we're on chapter 7. Remember back to chapter 2. We learned this thing called the third angles theorem. If 2 angles are the same, then the third is automatically the same. That was yesterday. Time just goes by so fast when you're having fun. Okay. All right, let's write our congruent angles. Angle A is congruent to angle D. Angle C is congruent to angle F. Angle B is congruent to angle E. Okay, now let's write our corresponding sides. So I'm going to go 1 to 2. So that's A, C, to what? DF. 2 to 3 is CB, 2 to 3, CB, 2 to 3, FE. So we got 1 to 2, 2 to 3, now let's go 3 to 1. BA, 2, ED. Mm-hmm. Okay, so now let's go back and plug in all these numbers for them. So AC was 10.5 to 7. 9 to 6. And 6 to 4. So our next thing we need to do is plug these in and see if they all equal the same thing. Y'all be nice to one another. Jeez. Okay, when I plug all these in my calculator, because I wanted to, I find that they all have the same scale factor. Now remember, so they are similar. That was our question. Are they similar? Yes. So the scale factor needs to be a ratio. So if it was 1.5, I would know that that means the scale factor is 3/2. Okay, leave it as a fraction, not a decimal. What's left? There's one more thing we haven't done. The statement. Triangle ACB is similar to triangle DFE. Now, is it okay if you went in a different order? As long as you are consistent. Thank you. I lost my word. Okay, can you try number 2 for me? Thank you so much. Guys, if you want to skip this part, I'm okay with that as long as it does not ask for it. Did it ask for you to write the corresponding sides? Okay, then I'm okay with you skipping straight from this to this. But if you're not confident, then don't do it. Okay. So if that's 1 to 2, 1 to 2, I would have 16 to 24. And then this is 3, 3. So then 2 to 3 would be 14 to 21. And then we'd have 12 to 18. What was their scale factor? 2/3? Do they all have the same scale factor? Okay, we'll trust you. How did they know that, Ms. Jenkins? Well, 16 divided by 23, 14 divided by 21, 12 divided by 18. Well, all of these, besides this one that I goofed on, is 0.6 repeating, which we know is 2/3. Okay, so they are similar. There are 3 congruent angles. So the similarity statement would be, you could write a couple different ways. ABC is similar to UVT. Alright, skip 3 for now. Let's go to the back. Okay, so now, we're no longer proving they're similar. We are told that they are similar. Okay? I'm telling you, they're similar. You don't have to prove it. Now that they're similar, they have the same scale factor. So let's find X and Y. Well, what I personally like to do is I like to go around and put symbols with corresponding sides. Like right here, 4. It has 1 to 2. 1 rainbow to 2. So it's corresponding with which side over here? AB, which is 6. Okay, look down at 8. It goes, now in this case, they're all on the same side, right? But not always are they like that. That's why I like to put symbols and double check. This one has 1, 2, 3, 4, 2, 1, 2, 3, 4, 5. So this is 4 to 5. So it's corresponding with Y plus 1. 3 is corresponding with X. Okay, now in order to find X and Y, we're going to have to set up 2 different proportions. But in these proportions, you want one ratio to be completely filled in. Well, which ratio? 4 to 6, 3 to X, Y plus 1 to 8. Which one's the only one that has numbers in it completely? 4 to 6. So let's use 4 to 6. And then now let's solve for X. Well, over here, doesn't 3 correspond with X? So if we wrote the ratio 4 to 6 is equal to 3 to X, what can I do to solve? Cross multiply. So you get 4X equals 18, and X is equal to, now we're just solving for X. So you can have a decimal. It's not a ratio. We're solving for X and Y. So that would be your answer. Now to solve for Y, I would use 4 to 6 again. And then instead of using 3 to X, we would use Y plus 1 to 8. And then we would cross multiply again. Okay, if I was going to start number 4, 1 to 2, that's here, 1 to 2, that's here, so I know those 2 are corresponding. I know that I have 2.5 right here, but it's corresponding to this, and there's nothing there, so I can't use it. And then 1 to 3, so this is corresponding to this. So let's solve a ratio. Let's set up a ratio to solve for X. Well, we have 4.5 to X is equal to what? 10 to 5. Solve. Notice, I set up two proportions. First one I started with this polygon. Second one I started with this polygon. Did I get the same thing? Yes. So it doesn't matter which one you start with, just be consistent. Okay? What I want you to finish before tomorrow are the 3 on your notes that we did not finish. So I want you to finish 3, 5, and 6.